Hello, this is my lab report for Lab 4. So the purpose of this lab was to take a video of a spring mass system in which the mass swings in an arc while oscillating on the spring, and then use the tracker software to analyze the motion and graph the position versus time of the x and y. And then I used Newton's second law and the principles for spring force and gravitational force in order to model the position versus time with Python code, and then I use the energy principle to graph the changes in energy, which includes kinetic energy, gravitational potential energy, and spring potential energy. So this is what it looks like in the tracker. So I have the x and y data, which will be my experimental data. And then the physics principles I use to model the position versus time is the formula for kinetic energy, gravitational potential energy, and spring potential energy, which are equal to 1/2 mv squared, mgh, and 1/2 times the k stiffness constant times s squared, s being the compressed or extended length minus the length of the spring at rest, and then adding those together equals the total energy. And then I use the formula for gravitational force, which is negative mg, with g being equal to 9.1, and then the spring force energy, which is negative the k constant times s times the unit vector L. And then adding those two forces together gets to the net force. And then using the momentum principle, I found the position update formula and the velocity update formula, and I used the F net from here in the velocity update formula. And then in order to graph the changes in energy, I use the energy principle, which says that the change in the energy of the system is equal to the total changes in energy. The change in rest energy is just going to be 0, so it's just going to be equal to the change in kinetic energy plus the change in these two potential energy. And then the change in the energy of the system is equal to the work of the surrounding if we don't look at the heat, and I will talk more about that one in the what does it mean question. And then a few data values I have is the mass of what the spring is holding, the initial position found with the tracker, initial velocity is just 0 because it starts at rest, the time of the first observation is 0, delta t is equal to 1 over the 2 times the frame rate, the length of the spring is 0.7 meters, and the t is used, the oscillating time period is used with the y. And I plug that into the formula for t equals 2 pi times the square root of m over k, and solve for k to get 6.833. And then I used the fact that the gravitational force the magnitude of gravitational force is equal to the magnitude of the spring force in order to find L naught. So in the Python code, I have these initial values here, a few more initial values, and then here I have that S, which is equal to the magnitude of the length minus the relaxed length. Here I have the formulas for the energies. Here I have the formula for net force. Here I have the position and velocity update formulas, and here I have the changes in energy. So if I run that, this is what it looks like. So we have all the changes in the energies, and you can see that when the gravitational potential energy is at its lowest, the spring potential energy is at its highest, and vice versa. And then the kinetic energy, change in kinetic energy is also going up and down, and the change in the energy will always be 0. And then here is the difference between the model and experiment position versus time. The experiment position versus time is can be a little bit different from the model. This could be because I use the y oscillating period and not the x. And then here we could see that it's also, the model experiment is also pretty similar, but the model has higher maximums, which could be as a result of some inaccuracy in the starting displacement. And so for my what does it mean question, is the energy principle satisfied? And yes, it is satisfied because the change in energy of the system is equal to the change in kinetic energy plus the change in gravitational potential energy and the change in the spring potential energy, and that will be equal to 0 because the work of the surrounding is 0, because we consider the Earth and the spring and the mass as part of one system. And then I have my period of oscillation for both the x position and the y position, and they are pretty different. So if I were to use the x oscillation period instead of the y, I would get different results for my model data. Thank you.